Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs. Now we are going to learn how to find overall thrust and overall mass flow rate of Atlas-2 missile. Consider the MA3 multiple liquid engine for the Atlas-2 missile had two booster engines. Thrust F is 165,000 pound-force at sea level and m dot mass flow rate is 667 pound-meter per second each. The turbine exhaust gas of both boosters adds an extra 2,300 pound-force of thrust at a propellant flow rate of about 33 pound-meter per second. These booster engines are dropped from the vehicle after about 145 seconds operation. The central sustainer rocket engine, which also starts at liftoff, operates for a total 300 seconds. It has a sea level thrust of 57,000 pound-force and altitude thrust of 70,000 pound-force, both at a mass flow of 270.5 pound-meter per second. Its turbine exhaust gases are aspirated into the nozzle of the engine and do not directly contribute to the thrust. There are also two small vernier engines used for roll control of the vehicle during the sustainer only portion of the flight. They each have an altitude thrust of 415 pound-force with a propellant flow of 2.13 pound-meter per second. Determine the overall thrust F suffix OA and the overall mass flow rate m dot suffix OA at liftoff and at altitude when all the nozzles are pointing vertically down. Given data. Here we consider Atlas-2 missile of multiple liquid engine. Missile had two booster engine. Let's assume that this is first stage. At this stage, boosters has a thrust F1 of 165,000 pound-force at a mass flow rate m dot 1 of 667 pound-meter per second. Here, the two boosters turbine produce exhaust gas, which adds an extra thrust F2 of 2,300 pound-force at a mass flow rate m dot 2 of 33 pound-meter per second. First stage lasts for 145 seconds. Now take this as T1 and then the booster engines are dropped from the missile. Then at liftoff, central sustainer rocket engine starts and it lasted for 300 seconds, which is T2. Sustainer rocket engine has sea level thrust F suffix 3s of 57,000 pound-force. Also has altitude thrust F suffix 3a of 70,000 pound-force. They both at the same mass flow rate m dot suffix 3 of 270.5 pound-meter per second. And also here two small vernier engine. They each have altitude thrust F4 of 415 pound-force at propellant flow of m dot 4 2.13 pound-meter per second. Now we have to put the overall thrust and the overall mass flow rate at liftoff and at altitude. So overall thrust F suffix OA is needed for determining the vehicle's flight path and the overall mass flow rate m dot suffix OA is needed for determining the vehicle's mass. Together they determine the overall specific impulse. First, find the overall thrust at liftoff. At sea level, overall thrust includes thrust of two booster, which is F1, and thrust by turbine exhaust gas F2, and sea level thrust of sustainer engine F suffix 3s. So write f suffix OA is equal to 2 into F1 plus F2 plus F suffix 3s. Now substitute the known values and simplify. We get the overall thrust at liftoff is 389,300 pound force. Similarly for overall mass flow rate at sea level. Mass flow rate of 2 booster m.1, propellant flow by turbine exhaust gas which is m.2, and propellant flow at sea level of sustainer engine m.3 can be included. Then we can write m dot suffix OA is equal to 2 into m.1 plus m.2 plus m.3. Now substitute the appropriate values and solve. We have the overall mass flow rate at sea level is 1637.5 pound meter per second. Next, find out the overall thrust and mass flow rate at altitude. Now add the thrust those are produced at altitude. So at altitude, the altitude thrust of sustainer engine F suffix 3A and thrust of 2 small vernier engines F4 can be included. Thus we can write F suffix OA is equal to F suffix 3A plus 2 into F4, which is at altitude. Solve this equation with suitable values. We get the overall thrust at altitude is 70,830 pound force. Similarly for mass flow rate. Mass flow rate of sustainer engine m.3A and propellant flow rate of 2 small vernier engines which is m.4 can be included for mass flow rate at altitude. So we can write m dot suffix OA is equal to m dot suffix 3A plus 2 into m dot 4. Now substitute the values and simplify. We get the overall mass flow rate at altitude is 274.76 pound meter per second. Did you know? Colonization. The use of metallic cylinder rocket artillery came along in 1792 when the rulers of Mysore in India developed the technology. After they were defeated by the British took these developments and expanded them further into the 19th century. Life after death. Jet Propulsion Laboratory maintained operations after a person's death and after developing the Explorer 1 satellite, which commenced America's entry into the space race with the Soviet Union. It was integrated into the National Aeronautics and Space Administration. Out of service. The Lunar Space Station was split between Russians and Americans, and they got along great over the first few years. That is, until the Russians' eating habits got in the way. Because of their diet, the Russians were prone to clogging the shared toilets, so the Americans banned them from their half of the station.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired and fly high.